This video is intended to help you learn how to graph a solution to a system of inequalities. Realize that a system of inequalities is going to have a whole shaded region full of answers. So it may be what's called a bounded region, such as the green region up here on the right, described down here at the lower left. A bounded region is a closed feasible region, or a region where there's a limited area full of answers. Realize there are still an infinite number of answers, however, because you might have an answer, think as simple as a number line. As you're looking along that line of answers at the bottom, you could have an answer somewhere like 3. You could also have an answer somewhere like 4, or literally anywhere in between. And every time you name a point that's in between, such as 3.5, I could name a point somewhere between that and 4. And you can always keep finding infinite numbers of points using decimals in between those points. While in a whole shaded area, you could also move up and down or left and right. You can move all over that green area, and there are technically an infinite number of points, even in the bounded region there. An unbounded region is one more like the purple one down here at the bottom, where now there's an infinite amount of area and an infinite number of answers because there's no closed side. That purple line is bounded on the top and on sort of the top left and top right, but it's infinitely extending downwards. There's no limitation on the bottom. So that is an unbounded region. Again, the constraints are what the black lines are called. They're with bounding or at least closing off portions of our region of answers. And the feasible region is the area of the graph containing that infinite number of solutions to a system. Because they're an infinite number, the best thing that we can do is graph the system. We can't actually list off all of the answers. All we could do at best is list off possible examples. So let's say we were given the system here at the top. The first thing we would want to do in order to graph the system would be go ahead and solve these equations for y. So for the top equation, I'm going to say that negative y is less than or equal to negative 3x plus 2. And if I divide by negative 1, y then will be greater than or equal to, remember to flip your sign because we divided by a negative, positive 3x minus 2. I could then go on my graph down to negative 2, up 1, 2, 3, and to the right. And I could make, since there is an equal sign, a nice solid line through those points up and to the right and down to the left. You want to make that nice and long, covering your whole graph, because we're not sure where the shaded region will be yet. Now, if we take that second equation, so the one in the middle here, and go ahead and solve that for y, y will be less than or equal to negative 2x plus 1. So we can go on to our graph. Maybe we'll graph that in blue. Go up 1 with a slope of negative 2, down 2, right 1 on there. And notice it also has an equal sign. So we can make a nice solid line all the way down our graph. At this point, we could start to decide whether or not we want to graph above or below our lines. Remember, we can either check a point, so pick a random point like 0, 0, and plug it in, 0 being greater than or equal to 3 times 0 minus 2. Is 0 greater than or equal to negative 2? And I would say that yes, it is. So I'm going to shade towards 0, 0, or essentially above the black line. Give myself a little note there that I'm going to be on the top side of that black line. We could also plug 0, 0 into the yellow side, or just observe that y is less than our equation, which means that I'm going to be below, we're going to have all y values below the blue line, which means that we're on this side of our blue line. So far I'm sort of to the left side of both of my lines, or in this shaded region over here to the left. The last thing I'm going to do is go ahead and graph my final line here. X is greater than negative 4. So if I go over to x is negative 4 and draw a nice vertical dashed line, notice it doesn't have an equal sign, but x is greater than, which means thinking about x, greater than is to the right. I'm going to be to the right side of that orange line, which means I better extend my lines a little bit. This blue line needs to connect to the orange here, and the black line technically needs to extend out so we can connect down there. We'll have to imagine that happening because I made my graph a little too small. Well, we're on the left side of the blue line, left of the black line, and to the right of the orange, so we're kind of in the middle of this whole region of answers here. And again, infinitely down to where those lines would connect, all the way over to that intersection point way over there at the right. But we don't have to actually find those points. One of the nice parts about inequalities, that shaded region is the solution to our system. So go ahead and take a minute. Here's another solution or a set of inequalities. Go ahead and take the graph and see if you can't find the solution set or the graph of the solution set for our system. Pause the video and see what you can do. Alright, I've got everything worked out except for the shaded portion on this one. The first thing to realize is x is greater than is just anywhere to the right of, x is greater than 0, anywhere to the right of the y-axis. Y is greater than or equal to 0 is anywhere above the x-axis. So together, that means that we're up in quadrant 1, so we're somewhere up here. So now the only real question is, am I shaded above the purple line or below it? The purple line, by the way, I found by finding intercepts since we were in standard form. I just plugged in 0 for x and 0 for y separately and figured out what y-coordinate would give me 0 for x, what x-coordinate would give me 0 for y, plotted my 0, 8 for my y-intercept and 6, 0 for my x-intercept. The last thing to do again is just to check a point. So at 0, 0, and definitely not on the purple line. So if I say 4 times 0 plus 3 times 0 greater than or equal to 24, well 0 greater than 24 is definitely a false statement. So we are going to be above, up in quadrant 1 as we said before, but above the purple line. So only out in this shaded region out here. Remember, do not cross that axis here. Don't cross the purple line as you get close to it there, and don't cross the y-axis up top. We're just out in quadrant 1. Definitely an unbounded, as it goes infinitely up and to the right, unbounded region of answers. I hope that helps you understand graphing inequalities. Have a great day and good luck.